The objective of this video is to show you how to make a Unity editor tool which will make a build and then automatically upload that build to Steamworks. There are three main parts. First would be setting up the Steamworks SDK, then making a Unity custom editor tool which is capable of calling it, and then third to make a custom build tool for making builds. After that, the rest is optional quality of life stuff. The first step is to download the Steamworks SDK from the website. Unpack this somewhere outside of your project. I've created a templates folder for organizational purposes where I'll put the scripts needed to be created. Inside the location shown, we can find example scripts that we can use as templates, such as the app build 1000 and the depot build 1001. The three main file types are app files, batch files, and depot files. If you are curious exactly what they do, you can look it up, but I will show you how to fill them and use them. Let's start by creating the app files. Copy-paste them over from the template shown earlier, and give them a name. Each one should correspond to the name of one of your app IDs. You will find your app IDs in your Steamworks page. Many of you may only have one, your production. However, some of you may have multiple, like your demo app, your playtest app, and your main production app. I also have a fourth one, a sub-branch, an experimental beta branch within my playtest. I now go over to the depot files, copy-pasting over the template mentioned before, and editing the names so they match my depot IDs. The depot IDs can be found in Steam Pipe. You can see the depot ID included here, but if you have no pushes yet, you can go to Steam, Depot, and find it there. Now let's start by editing the contents of our depot file. Alright, the finished contents should look like this. We have our depot ID, we have where the project is, where the depot is to upload. Then we have the specific project to upload within that depot. Let's see some examples. So, that location points here to our build depot where all of our builds will go, and it points specifically to the Steam production one. So this is where our build needs to be in order to upload. This is what an app ID file looks like. We need to put in our app ID, a description is helpful, and it must point to the depot that belongs to this app ID. If we have branches, well then we would have two different depots we point to with the same app. Now this is the final resting location for those two files we built, the app and the depot files. So copy-paste them over from your template and put them in here once they've been filled out. Next we will take a look at our batch files. Our batch files are the ones that will run the Steam command to commence the upload. The Steam executable can be found at this location. Our batch command will run this executable passing in the appropriate app ID to upload our project. Here is what a batch file looks like. As you see, it points to the Steam batch command and to the appropriate app file. Very important is if you are using SteamGuard two-factor authentication, do not include the password. If you are not using two-factor authentication, you must include the password, which means that your password is saved locally on a text file, which is very insecure. It is recommended to use two-factor authentication. This is all in one line of code, by the way, not two. It just looks that way. So as you can see, this batch file is targeting this specific app file, or this app ID, and that app ID was our production ID. That app file, if we were to open it, has a reference to the depot, which was the depot that we have when we open that app. You click on the app, you go to Steam Pipe, you go to depot. And in that depot file, it pointed to /steam production, which was pointing to the folder location content /builder, which was where we put our builds, right? So that's how that's all connected. This is the proper location for your batch files. Bring them over here. It is time to run the Steam command for the first time in order to install and update your Steamworks project. Log in by typing login, your username, and your password. It will probably ask you for additional authentication. If you are using two-factor authentication, it will ask you for your SteamGuard code here. If you are using two-factor authentication, this is very important. Type info. It will generate a config file. So now is a good time to test. So put in an appropriately named project, which is referenced by your depot file, in this location here. We can then run the steam batch command, which should run everything and upload. You can go to the Steamworks website and check if the upload had been received. Then you can set the branch live. We have now completed the first step, which is setting up Steamworks. Our next objective is to create a menu item which will run the Steam process. I have created a simple menu item template to show the uploading process. Our menu item, which will appear in the Unity Editor tool, we'll call upload process. It will use system diagnosis process.start to execute our batch command. Let's test that first before moving forward. So we run it and we check on Steamworks to ensure that it worked before moving forward. If you do not know much about editor scripting, it is a very powerful tool and deep rabbit hole. You can follow guides online for more information. Currently the issue with this is that it involves us making a manual build by using the normal build settings tool and then copy-pasting the build that we made over into the Steamworks folder. So here's a simple example of the build tool. This function will call and create a build using the build player. The build player has two main important parts. The argument that is passed, the build player options. It includes things like the scenes, the paths to build to, options, and so on. The next is player settings. When you make a build normally, the player settings here are used. When you make a build in the editor tool, it also uses these player settings as well, even though they're not passed as arguments. Think of them as static variables. So the options like IL2CP build, should it run in window mode, run in background. Here I have a function called set player settings. Depending on the build type, such as Steam production or demo or playtest, I use different player settings. So player settings, like I said, is static. You set the values. Now, it is very important to save them because you're going to have to set them back. Setting them is permanent and will forever change them. So I store them in a static variable. And then when the build is finished, I make sure to set them back. Here's what our simple menu item now looks like. We set player settings, we build, we move the build over to the Steamworks folder, we call upload, and we reset the player settings. As with every step forward, we want to run, test, and make sure it works, and that it appears on the Steamworks page. There are folders you should make sure not to accidentally upload. I clear out and delete those folders before copy-pasting the project over to Steamworks. We have now seen how to set up the Steam Build Editor tool. We have set up Steamworks. We have a Unity Editor tool which could make a build, send it over to Steamworks, and then call Steamworks to upload the build. And that should be good enough for most cases. If you don't have a demo branch or a playtest branch, or a solo developer, this should be enough to be able to automate the process. So now if you do have multiple app types or planning for them in the future, like demos, playtests, and beta branches, if there is more than one DevOps member in your team, or you have a backup DevOps member, or you want to be able to do some sort of custom logic before making builds and things like that. So I'm going to showcase some of the stuff that I added to mine in order to maintain scalability and also improve quality of life, and reduce the chance of making errors when handling multiple productions and branches. So as you can see, my build process is a little bit more complicated than the example that I gave earlier. My tool can support many different types of builds, which require different files, different compile time constants, and so on, as well as the difference between local builds and builds that automatically upload. My menu items look like this. They all call the same make build function, but they pass in different parameters depending on the build type. Because I am using a menu item to run the build, that means I can choose to run code before running the build. This allows me to pre-bake things, such as JSON systems, language files, and so on, before making the build. The next tool I created is for compile time constants. You've probably seen the famous if Unity editor compile time constant, but we can also make our own. This means that if it's a demo build or recording build, we can have it compile differently, running different code, showing different levels or maps, or so on. Normally, we have to go into player settings to set them up. However, we have to do this constantly, manually. The chance of making a mistake and accidentally uploading a demo build to production is very possible. Here is just my code for adding symbols and removing symbols. By passing in enum, I convert the enum to a string which represents the symbol. We need to make sure to remove the symbols afterwards, because if we leave them in there, it will slowly bloat up and, well, make us make builds that we didn't mean to make. When I set up the player settings, I also set the define symbols. When I finish making the build, I make sure to remove them. Be sure not to accidentally push them if something goes wrong with the build. The next is a lazy quality of life feature. I have it automatically, after the build is complete, open up Chrome at the location of where the build is so I can easily set the build live. Next is a trick for how I organize everything, and that's with enums. Steam Depot, Steam Experimental, Steam Playtest, and Steam Production are all values of enums, which I utilize in many different places. So the next is a simple trick where basically I use enums to represent the different types of builds. Before, we had to hardcode our paths. We hardcoded the batch path and we hardcoded the build path. Instead, we will just make them variable and inject the enum as a string. This allows the support scalability for introducing new types of builds without having to do much additional work. So as we can see here, here's an example of setting the location path name to be using the build type, as well as copying files and folders, renaming the appropriate folders so they have the correct name in the Steamworks location, and of course when doing the upload at the end, calling the appropriate batch file based on the name of the build type. The next thing that I have is something that ensures that only the appropriate streaming asset files go over depending on the build type. A production build, a demo build, and a developer build do not have access to all the same content, so we ensure that we only copy over the correct content based on the publisher build type. Now, it could be very possible that you have more than one workstation, that you'll need to upgrade the SDK in the future, or there is more than one DevOps developer. It is always good to have at least one backup DevOps developer. So I made a setup function. The setup function does two things. First, it selects where local builds will go, and second is you select the Steamworks folder. This will save both paths as player prefs in your system. If we go to our template files from earlier, my template files actually look a little bit different. They look like this. They have two placeholders for the build locations that we need to send them to. I then simply do a string parse, inject the locations, and then copy paste the folders to the correct location, so that way it's a single click setup for any workstation. So it's important to note that in a few months from now we'll probably forget how to do this. So it's important to include a menu item which just opens a website like we did earlier. That just brings us to a documentation site that explains how to set up the process. And that wraps up the quality of life features that can be added to improve the scalability of your dev tool. This video has been sponsored by me. If you feel this video has saved you a lot of time, then please return the favor by subscribing to the Galactic Thunderdome YouTube channel and liking our weekly short 40-second videos. It will then show our game to people who have similar profiles as you. Each individual largely multiplies our reach. It will greatly free time away from marketing so we can make more tutorials. Thank you.